Hey everyone, welcome to week 26, day one video on demand. We are going to knock out these four starters and then talk about translating equations. Guys, we talked about translating expressions in the previous unit, but today we're going to be translating equations, which has the same skill set, just a step further than where we left off. So let's go ahead and start by solving all four of these real quick. Let's start with number one, and right off the bat, they are throwing decimals back at you. So there is no reason to overthink these, regardless if it's decimals or if they're whole numbers. Either way, we're going to use the same list of steps or algorithm to solve. So I'm going to go ahead and write this down. I'm going to draw my bar, and then we need to go ahead and get this solved. So the first thing that we always do, we want to make sure that we start with the constant. That's a number that kind of hangs out by itself on the variable side. In this situation, the 4 is on the variable side and it's not attached to the letter. So that's the constant. I need to get rid of that. To do that, we need to do the inverse operation of plus 4 plus 4. Okay, that cancels here, and I like to mark them out just so I don't accidentally bring them down, leaving us with 2.5x equals 45. Okay. Now, at this point, we've got our coefficient variable and a constant that kind of hangs out over on its own side. We're going to divide this coefficient off because it said when these two touch, that means multiply. So the inverse operation would be division. We're going to divide by 2.5, divide by 2.5. That cancels all of this, leaving x equals, and then 45 divided by 2.5. I'm going to grab my calculator just to be sure. Don't be afraid to do the same. 45 divided by 2.5 is 18. 18. Let's see if that lights up green here. 18. And we are good. Let's go ahead and jump to the second problem. I've got 4x minus 16 equals negative 20. Now, you'd think that maybe this was a little easier because they're more whole number-y and no decimal involved. But I had more people miss number 2 than I had miss number 1 because of this negative 20 over here. So again, you've got to be principled, take a principled approach at every problem. So when you're going into this, we need to make sure that we're doing what we think is right. So first, we start on the variable side. We need to get rid of the constant. The constant here is minus 16. So to get rid of minus 16, we're going to do the inverse operation, which is plus 16. Plus 16. The most common mistake here was not the plus 16. You all got that part, most of you. It's negative 20 plus 16. I know it doesn't look like you need a calculator there, but you should always at least check it. Negative 20 plus 16 is negative 4. Okay. Now I need to get rid of the 4. It shows multiplication, so I'm going to divide by 4, divide by 4. The 4's cancel, leaving me x equals, and if I were to type in negative 4 divided by 4, that would get me negative 1. But I knew that because 4 goes into 4 one time, and negative divided by a positive is a negative. Let's see if negative 1 lights up green. And it does. All right, we got 2 more to go for our starter. Let's go ahead and get a new space. We've got 16x plus 8 equals 88. Now, I think this one's the easiest one on the page because there's no negatives really involved, and we just need to make sure that we're going through our steps or algorithm correctly. All right. First things first, we need to start with the constant. That's the 8 kind of hanging out by itself. And we start that not because it's the second number in this equation, but because it's hanging out by itself. So it says plus 8, so we're going to minus 8. Minus 8. That's going to cancel here. 16x equals 80. And then I'm going to divide by 16 on both sides. Divide by 16, divide by 16. X equals 5. You type that in the calculator, I think. All right. And then last but not least, I have to move the camera for this one. All right, back to decimals. Don't overthink this part. It's the same list of steps. So we're gonna draw the bar. We need to get rid of the constant first. And when I look at this equation, we get rid of the constant that's on the variable side. So x's side, and then the number that hangs out by itself. So we need to get rid of plus 5. So we're going to do minus 5, minus 5. That's going to cancel and get us 1.5x equals 27. Okay. And then we need to divide this coefficient off because it shows multiplication. So we're going to divide by 1.5, divide by 1.5. That's going to cancel all of that, leaving x equals 27 divided by 1.5. And I get 18 again. And that gets me all 4 points for this slide. Hopefully you are watching and working through those together. Solving equations is probably one of the most used skills going into 8th grade math. So it's one of those that if there's something that you don't want to skip over, this is probably it. All right, let's jump over to slide 2 and get to this translating expressions part. I think that this section, I know solving equations can be hard, don't get me wrong. But I think that translating anything from words into number form can be some of the hardest stuff because order matters in a lot of it. And when order matters, you may need parentheses, you may not, and it all plays into it. So as we go down through here, you've seen these notes before, but we kind of skipped over the equals part because we didn't need equals on expressions. So these words mean equal. Is, are, were, was, and then will be, yields, and then sold for. So as you go through here, you're going to see a lot of these. And guys, there's probably words that aren't in this. This is just a general guide. Now, I think I think it has probably 90 or 80% of the words that can be used. But I think there's a few on the next page that they throw in some different words, and you have to really think about it. And if you have to Google a word, Google a word. There's no shame in that. All right. Believe it or not, you look at these, and we're going to do the top 3, and then I'm going to pause it, and I'm going to let you do these next 3 on your own, and then we'll go over them. But these look easy. They look easier, but I think these are the more difficult ones, and the word problems, and a lot of people in class also agree, these word problems are actually maybe even easier, right? So you just got to be careful about how you read everything. All right, let's start with the first one. It says, the sum of 8 and the product of 3 and x is 21. There were a lot of words that just came out. Let's read that a little bit slower. So first off, it says the sum. The sum in this situation, in all situations, we're going to be adding 2 things. So we're adding 8 and the product of 3 and x. So break it down. So that means we're going to add 8 in the product. Well, product means what? If you don't know, you can always flip back up and see if you can find it. Product here is in multiplication. So the product, so there's 2 operations here. It's not as hard as it looks. And then don't forget is equals and then 21. All right, so let me grab my mouse here. So we need 8 plus the product of 3 and x. So 3 and x is 21. Yeah. So not bad, not bad. The second one is very similarly worded, but different. So let's read this. It's 4 times the sum of 8 and a number. So we need to do 4 times the sum of those 2 things. So the sum of 8 and a number means 8 plus x, and then we need to do 4 times that. We can't do 4 times the sum of that without adding them first. So we need to use a set of parentheses here. So we're going to start with 8 plus x. And to multiply that by 4, we're going to put that in parentheses and multiply by 4 on the outside. And then we end with is 20. Now, very similarly worded problems. One had parentheses, one didn't. So how do you know when you use parentheses? There's a couple things. First off, sometimes they'll use these words up here in the parentheses. This one did not. The reason we use parentheses here is because we have to do 4 times the sum, and we can't do the sum. We can't multiply 4 by the sum or the answer to an addition problem without doing that first. So to do it first in order of operations, you have to put it in parentheses if it's out of order. So addition comes after multiplication, so that we need to show to do that first. All right, and then this one, they may be a little harder at first, but then I think you'll catch on. It says the Bayer family has 6 family members. They need to buy tickets for X dollars, so we don't know how much the tickets are, and drinks for $2 for everyone in their family. So we're buying 6 tickets and 6 drinks. The cost for everything was 60. Write an equation for the situation. All right, so there's a couple ways you can write this. So we're going to write this 2 different ways. I like the first way, and I know I have several students who like the second way. It doesn't matter, because at the end of the day, as long as you get an equation down that tells this story, you're going to be fine. So we're not trying to solve. We do not need to know what x is. That's maybe a later point we'll solve for that. But right now, we're just simply trying to write an equation that represents this problem. So if we're buying 6 tickets and 6 drinks, we can do 6 times both. So we need to put both of those things in here. So the tickets were X. We don't know how much those were, and the drinks were 2. So we're doing 6 drinks. So we're doing 6 of both of these things. That's why we put them in parentheses. And then they said the total was 60. That's my favorite way. Whenever you see something multiplied by the same number, 2 different things multiplied by the same number, you can use parentheses to multiply both of them by 6. Now, I have a couple people who would say, "Oh, we're buying 6 tickets." That's right. Absolutely. We are buying 6 tickets. But the secret here is you've got to be careful with the drinks, because you bought 6 drinks. That's going to be $12, not $2. So if you don't use parentheses, make sure you go ahead and do that math, so that when you make your equation, it's correct. So I'm happy with either one of these. I like this one personally. It's the most raw equation. This one, you did a little work to get there, but sometimes that just makes more sense, and that's okay. It's okay. All right, now's a good time to pause. I want you to go ahead and knock out all 3 of these, and then we'll meet back and go over them. All right, guys, hopefully you got a chance to knock those out. Let's see how we did. So it says the difference between, so difference means subtract. So I like to sometimes highlight important parts. The difference between 3 times the number and 4. And is what separates the 2 things that you subtract. I think that's like, it took me a long time when I was your age to figure that out. So we know that we're going to do 3 times a number and 4, and we're going to subtract those 2 things. And then we'll get to the is part at the end, because it's pretty self-explanatory. So, so 3 times a number first. Mouse. 3 times a number, 3 times a number, and the difference between that and 4. Okay. We do not need parentheses because multiplication comes first, and that happens before subtraction, so we don't have to worry about putting parentheses anywhere. Okay, and then is 42. That's it. That's it. All right, this one's a little easier. It says the sum of 9 and x equals 41. So you just really need to know what the sum is. In this situation, let's see, the sum of 9 and x equals 41. Okay. So 9, and then sum means add. Add the sum of 9 and x equals 41. The last one, I think the key to this one is if you're repeating something, it's likely to have a variable, because you're going to have to multiply it by however many we have. And if we don't know what that is, we're going to multiply that by x. So in this situation, let's read this. It says Sarah has to pay $40 for voice on her cell phone and 10 cents a text message. Last month, her bill was $60. Write an equation. Okay. So let's tell this story again. So Sarah pays $40. So this is just a monthly bill. That does not repeat. She just pays $40. That's it. Now, she has to pay 10 cents a text. So when we write this, she's going to pay 10 cents, right? Oops, sorry, plus. It's plus because it's going to make the bill go higher. So we have 10 cents, and then we don't know how many texts Sarah sent yet. So we're going to put X because we're going to multiply that. We're going to multiply that 10 cents by however many text messages she sent. The bill totaled in $60. So totaled in 60. And we're done. So the secret here is the 40 doesn't repeat, but the 10 cents does. So that's how you know that that's going to be the thing that's attached to the X. So as you go through these word problems are going to be a little tricky. So just make sure you hold on to it and just try to figure it out. All right. Jump into slide 3. I think we have 5 slides today. I'm going to do 3 random questions from the first 10 questions. Then we're going to pause and you can work your way through it. Again, as usual, if you're having trouble with these, which is very common, don't feel overly stressed out about it. Just reach out through Canvas Messenger, and I'd be glad to sit down with you during office hours and work through these, or on Friday if you need me to hop back and do a couple. All right, so let's choose 3 random ones. I'm going to do 3, 6, and 9, and then maybe we'll do a couple more. But you have to read these extra careful. All right. Combine, that means add. 3 and, so we're gonna combine 3 and then 5 times j. Combine 3 and 5 times j. So we're gonna add those two, and that gives us 18. So 3 and 5 times j. Okay, that looks good. Gives 18. I think the hard part here is sometimes we want to multiply across and use parentheses, but in this case, it's just 5 times the j. So you got to be careful. Just read carefully. All right, let's try 6. And this is a good one because it has a word that we've never seen, at least in this class. Twice of x diminished. That means it's gonna fall. It's gonna decrease by 9. So decrease, when you're decreasing something by 9, we're gonna subtract that by 9. Equals 5 times x. Ooh, there's a lot going on there. So let's focus on breaking it down. So twice of x. So we're gonna multiply x by 2. Okay, diminished by 9. That's a different part. Diminished by 9. And then equals 5 times x. That part's not too complicated. So let's slow it down here. So twice, so let me grab my twice x, okay, diminished by 9 equals 5 times x. And now we wouldn't be able to solve that because there's variables on both sides, but at the end of the day, we can certainly write that equation. All right, let's take a look at 9. It says half of k increased by 1 is equivalent to 7. So half of k, there's a couple ways you can do it. You could multiply it by a half, but most people, to find half of something, they'll just do divide by 2. So half of k increased by 1, that means we're going to add 1 to it, is equivalent to 7. All right, guys, that's 3, 6, and 9. I'm going to go ahead and do 10. It has another weird word in it. And then if you all need help on any of these, just please reach out because we will not be going over all of these. It says subtract 4 from thrice of c is 7 times c. All right, so there's a lot going on. Subtract 4 from, ooh, that's a key word. That's a big word. So from, so that means we're going to take 4 away from it. So it's not going to be 4 minus thrice of c. It's going to be thrice of c minus 4. Careful there because that's an order situation. Let's grab my line. Thrice of c is also a keyword. And then we're going to focus on is next. So let's just get this first part down. So thrice is like twice, but instead of times 2, it's times 3. So thrice, let me grab my mouse. Thrice of c, subtract 4. Now, just to be clear, a lot of people would do this. 4 minus 3x. That's not going to be correct here. It's not going to be correct here because order matters. You're subtracting 4 from it. So it's going to be 3x minus 4. And then it says is 7 times c. 7c. Let's see. Did I goof up? Not divide by 3. Subtract 4 from thrice of c Oh, it's C. Goodness gracious. Okay. I was like, what did I do wrong? See, even I get caught up in the words there. I just put the wrong letter in. So we've got 4 of them down. That leaves you with 6. I'm going to give you a second to pause, try to work your way through it. If you have any questions, again, shoot me a Canvas message. We can meet on here during office hours and work these out. All right, let's jump down to these word problems. We have a few to knock out together. It says Val rented a bicycle while she was on vacation. She paid a flat rental fee of $55, so she pays that once, and then $8.50 per day. The total cost was $123. Write an equation to find out the number of days she rented the bicycle. So we don't need to solve it. We just need to write the equation. So she's going to pay $55 plus, and then 850. She's going to pay 850, but she's going to pay 850 for every day, and we don't know how many days it is. So we're going to multiply that by x equals, and then it says the total cost is 123. And that's it. So when it comes down to these word problems, just find the thing that repeats over and over again. Let's try another one. Let's try 13. It says Heather has $500 in her savings account. That's probably going to be equals 500. No, maybe not. She withdraws $20 a week for gas. Write an equation Heather can use to see how many weeks it will take her to have a balance of 220. All right. So she starts with 500. And she's taking out money. She's withdrawing it. So we're going to subtract 20 times however many weeks she pulls money out. So we don't know how many weeks that is. So we're going to put X. And then she ends up with a balance of 220. All right. I'm going to let you all solve 12 and 9. Now would be a good time to pause. And we'll get started on the next slide. All right, guys, let's jump to slide 4. Hopefully you've got most of your points, if not all of your points there. We're going to start with this word problem. They show a visual, which I actually like in this situation. So it says, Cole buys a new laptop for $335. He makes a down payment of $50 and pays the rest in 6 equal payments. What equation represents the relationship between the cost of the laptop and Cole's down payments? Cole's monthly payments. So their little model here, they put the cost of the laptop up top because that's the overall total, $335. Okay, and you all don't have to write this in. It's not a box for points, but you'll definitely want to watch. And then he pays a down payment of $50. So we're going to do a down payment of $50. All right, and then we're going to shove that in that little box there. And then the rest, which we don't know how much these payments are, but we know that he has 6 equal ones. So that's why they're the same size. So we know that the total is going to be $335. He pays $50. Okay. And then he has 6 equal payments. So he pays 6 payments of an undisclosed amount. So we put a letter. Down below, they just want you to rewrite that as an equation. 50 plus 6p. 335. Sorry. When you look at this, we know that 50 plus the 6 equal payments has to equal 335. That's why this bar model is a good indication of how you're going to write your equation. So the top bar is equal to the bottom. That's why we have 335 equals this equation. All right, let's go down. I'm going to do one more, and I'm going to do number 14. It starts by saying you want to buy a pet iguana. You already have $12 and plan to save $9 per week. Now, if you look at the picture closely, it shows the iguana is 48. Now, it does say to use the letter W. So it says if W represents the number of weeks until you have enough money to buy the iguana, what equation represents your plan to afford the iguana again? So we start with 12. That's not repeated. That's not how much we're saving per week. So we just leave that by itself. Now we're going to add more money every week. So we're going to do 9 times the amount of weeks. Now we don't know how many weeks we're going to save. So we just put W. And we put equals 48. Now I know that's right because 12 is by itself. It doesn't repeat. 9 is multiplied by the amount of weeks because it's $9 per week. And then we need a total of 48 to afford the iguana. It says, explain how you could set up an equation to find the amount of money you should save each week. So in this situation, instead of 9W, you would have 6W because it'd be 6 repeating weeks. So it'd be instead of 9W, we should have 6W in place of it. Like, so it'd be 12. We're still saving 12, and then 6W. Now, in this situation, the W doesn't stand for week, so we could change that to X because X is the dollar amount that we'd be saving each week, equals 48. So the equation changes a little. The variable may change if you wanted it to. It doesn't matter what the letter is going to be. But the variable wouldn't be weeks. It'd be the dollar saved per week. All right, guys, go down to 7. Again, if it repeats, that's what gets the variable attached to it. I'm going to let you go on your own, and then slide 5 is a Desmos activity that you'll need to jump through. The link is on your Canvas modules page, so that's where you'll want to go. Thank you all for tuning in, and I'll see you all at your next available class.